Hello, everybody. Welcome to ZIGURAT Tech Minds, Shaping Smart Cities. I'm Chris Dymond, and I'm going to be the host of this event. Thank you for joining me. I'm the founder of Unfolding, where I help stakeholders better understand how places are being reshaped and transformed by digital technologies. And I'm also the academic director of ZIGURAT's master's program in global smart city management. Today, we're going to be meeting very interesting people who are tackling complex challenges in cities with technological solutions. We'll be talking about intelligent urban ecosystems, about electric mobility and the implications of it, and about computational design. I should note that these conversations took place over several days at the beginning of March in 2024, because I'm talking to people in very different time zones to my own, people in Saudi Arabia and in Australia. So let's get to it. Hi, Tom. Welcome.
Chris, great to be here. Thanks.
Fantastic. Tell us a bit about yourself and your background in cities and technology, Tom.
So I guess I've spent my life in and around major technologies across sort of government, enterprise, and startup and scale up. So I came to Smart Cities Council through originally working across large technology providers, so EDS, HP, DXC, so global technology providers for broad-based solutions. Then spent quite a bit of time in financial services, but in engineering and large-scale infrastructure technology, so everything from data centers, cloud computing, network security, and everything in between. I ran technology and digital for PwC for South Australia, so one of the states in Australia. So that then had me more broadly engaged across transport, infrastructure, government, defence, space, mining, resources. So I guess through all of those experiences, I picked up more and more understanding of, I guess, the components that need to come together to help deliver major city services and outcomes. And then I joined Smart Cities Council a little over 6 months ago. And now from a smart cities perspective, the council for us is headquartered in Washington. It's the largest, longest running membership-based social impact organisation for smart cities, smart buildings and technologies. And we're across 20 plus, I think 22 countries now globally, but with a focus on the more macro policy, blueprints, designs, standards, etc., that can be universally applied across smart cities.
Yeah, great. So I mean, one of the things, obviously, we know that cities are being transformed by data and digital communications, device proliferation, compute power across all dimensions. So how do you think about this process, and so that you can better analyze it and make good decisions? I guess that ties into the standards efforts that you're doing with Smart Cities Council. So what's your kind of mental framework for kind of keeping everything in mind when thinking about these things?
Yeah, I guess what we're finding more and more as we work across the globe from a smart cities perspective is that the individual technologies, devices, sensors, solutions may be different depending on geography, provider, domain, but I guess the key foundations are relatively consistent, which is having an understanding of the ecosystem, knowing the maturity of your city or space in terms of where you are in the ability to utilize new technologies as they come along, And they have, I guess, some foundations around things like data, understanding of data, classification, use, control, etc. Just key elements around governance, risk, compliance. So, do you have strong frameworks around which you are then making decisions for the adoption of technology? So, it's more and more for us, we're seeing it's the foundation policies, guidelines, frameworks, standards that then enable smart decisions to be made, and the right selections of technologies for outcomes.
Right. Okay. So you can sort of compartmentalize it, break it down into, those components, and then make sure that those components are at a sufficient level of maturity so that they can provide value. And obviously, it's not just about the technology. You mentioned policies, and governance. Having the technology infrastructure in place is never enough. You need people to understand how to use it, and that's not just the technical people that are managing that service, or even the people that the service was designed for necessarily, but other stakeholders in the city that could benefit from the value that those services provide.
Yeah, we're actually seeing, as you obviously are in ZIGURAT, but a continued desire for increased education, awareness, so understanding of the fundamentals of what is a smart city, what are the components that make up a smart city, understanding even simple things, well, relatively simple, but how to procure and manage services, and how that looks different in an environment that might be a hybrid of traditional legacy type services and highly mature, advanced cloud or SaaS or other type services, and recognizing that even the contracts and procurements and supply chain management elements that need to go around that require a level of knowledge and sophistication in terms of how to operate those.
Yeah, and just because a new system or new service is sophisticated and cloud-based doesn't mean it's not proprietary.
Correct.
And so, those values around interoperability obviously are really crucial to the whole process as well. But I wanted to ask you also about, obviously, we teach a smart city management course. I mean, it's intended for people who have management responsibility for cities, not for people that build things technically. But we use the term smart cities, and you work for Smart Cities Council, which uses the term smart cities. Where do you sit with using smart city as a term? Do you think it conveys what we understand it to mean?
Look, this is probably one of those questions where it's something different to every individual, and I think the term itself probably had a lot of particular and specific meaning a number of years ago, and now it seems to have morphed a little bit into the use of any technology anywhere in the city. For us, smart cities is a term we like to apply to an overarching plan and strategy, and a desire to move from one point to another point, and having the steps in place or the roadmap, and how you might execute on that, rather than just one application of one particular technology, but recognizing equally that this can be very different. You could be a small, remote and regional community versus a greenfield new city build, and that what that looks like for you may be very different. I mean, we have examples. We're working into the likes of UN Habitat in Africa, where there's an overarching vision to build 173 new cities over the coming decades in Africa, and they are, they want to focus on those being smart cities, but it's recognizing that for that to work and for it to be successful, they need to be, self-sustainable, sustaining ecosystems, and that you can't apply the same expectation in terms of what that means for each city and expect it to work and produce the same outcome. So where their focus is understanding and aligning around the economic enabler for a city sector or region, and that may be different depending. So, in DRC, in Congo, they have some of the world's biggest lithium deposits. So what might, sustainable, more effective and, better managed mining and resources look like in Congo that supports that, and that takes some learnings from perhaps some of the challenges they've had in the past. But then, in Malawi, that's a very agriculture-focused ecosystem and industry, and so in that space, they're looking around how they can provide housing and support for those that are working into the agriculture industries, but also use that to enable them to buy their own houses, for example. So they have small farm plots attached to each of the new build houses that then enable people that are living there to also supplement income with market garden type farm plots that the families can work, and that can help them to pay off homes and but also feed back into growing that agriculture community. So some very different examples there.
But also examples that don't immediately shout technology.
No.
And so, and obviously policymakers, I mean, we see this around the world. There's thousands of new cities being built, some of which, very prominent, very large and very expensive.
Yep.
In areas where there are no cities, and often there are no cities there for a reason. People have not decided to set up home there because of the surrounding ecology. But policymakers want those cities to be smart cities, and they have quite a strong technology focus. So how is it? How do you marry those two things up? What's right for the sustainability of the city? You always think, you've got a plan to build a brand new city somewhere. You think, well, I always think, what's it going to look like in 200 years' time? And how is the city going to evolve and adapt to, the future?
And certainly, again, I think that's why for us, the focus is very much around having an ecosystem, with those policies, with the design and planning around these cities that has a view of what it needs to be and what it needs to look like in the future, but recognizing that that it needs to also match with population growth and spend, and that therefore having the right foundation components in that city that enable them to deliver outcomes now, but that also enable them to scale and grow in the right way and take advantage of new technologies as it makes sense for those cities.
Mm-hmm. And you talk about smart city ecosystems, and I presume part of that is a kind of multi-vendor environment as well, where you're essentially managing consortia of different companies and partners who are each providing a piece of value to the whole, but need to do so in a way that doesn't undermine the functioning of the whole thing as an ecosystem.
Yeah, and look, I think that's really key, and it's certainly a big focus for us, where it needs to have government, industry, and academia working harmoniously. Recognizing it's a slightly different makeup for different cities, but that you need to be able to support growth, companies from startups and scale-ups, that you need to be able to work with government, but also, supporting government and government outcomes. That things like grants and funding from government need to be able to go to the right places, have the most effective, both delivery channels, but also, target and means for actually providing outcomes. But equally, that the technologies, the use, etc., continues to grow and evolve, and so having the link to academia, to research, to be able to continue that sort of development life cycle, and have that grow with a city or community is equally key. So what we're seeing more and more so from our perspective is a need for this connected network of partners and organisations that can contribute directly to the problem spaces, to the opportunities that as they are presented by government or by large industry, but also recognise that sometimes that requires organisations then to partner with each other to either provide capacity where they may not have it, skills or otherwise in a specific area, or where capability uplift comes from combining two solutions, two products, services, and that oftentimes bringing two or more of those, two or more of the applications together will actually drive the best outcome. So, it might be that there's a fantastic use case that's been executed in Latin America that could have some great application in Africa, but there's some nuances with geography or government or whatever that actually means that you can't apply it directly. So, being able to recognise those and sort of build the relationships and partnerships across organisations to actually provide higher order, higher value offerings, I think it's key as well.
Mm-hmm. Yeah, that's really interesting. And it's one of the things. I mean, we teach many things. Obviously, it's a year-long master's program, but one of the things that we cover is how to evaluate initiatives in one part of the world in order to determine whether or not they may be successful in another part of the world. Like, what are the factors that are barriers that might be too hard to overcome, and what kind of things might be conducive, or how could it be reshaped to fit a particular context. So yeah, it's always very contextual. I wondered, you talked at the beginning about breaking things down into modules and maturity levels of the kind of the foundation of a smart city, and obviously most of the contexts that I'm involved in Europe are around transformation, digital transformation from one state of things to another. But as we've discussed, there are a lot of cities that are starting from scratch and have an opportunity to kind of to set the landscape for how the city is going to develop, technologically and socioeconomically. What kind of opportunity do you think that is? I mean, how concerned are you that mistakes are being made right at the beginning, or how enthusiastic are you about the opportunity that it presents to get things right from the beginning?
Look, I am I probably see myself much more as the eternal optimist than the other way around. So look, I'm definitely excited by the opportunities. I think when you look at some of the particular things like the rapid population growth in Africa, but that it's not necessarily supported by the same pace and scale of industrialization, then that means you're needing to solve problems differently. And I think that presents fantastic opportunities for innovative technologies or applications of existing technologies in new and innovative ways. But then I look at the potential, staring into these things as kind of more of a global community perspective and saying, actually solving some of these remote and regional community type challenges in parts of Australia actually have application in similar remote and regional type areas, whether it be in Africa or otherwise, and vice versa. So I do think the sharing of knowledge, the sharing of learnings, the sharing of failures is key to this. But I do think that there seems to be an appetite and organisation, certainly like ours, like what you guys are driving from education, learning awareness perspective at ZIGURAT. I do feel like there is more of a growing sort of global community around this. And so look, there will always be risks, particularly some of the greenfields sites where, depending on how quickly you're making decisions around these, that the risk of making key decisions, perhaps with not the right information or not enough of the information that you need. But I do think that we are getting increasingly better at taking those learnings from across the globe. I mean, we've got we've actually sort of built around smart cities a global thought leadership panel that says, okay, who are the people that have done this stuff the best around the world, and they're everywhere from sort of public safety, intelligent airports, cyber, could be smart tourism, night economy, all of these elements that sort of come together. And how do we get those learnings and actually turn them into material that people can consume, whether that's through micro and macro credentials, professional development material, or just publicly available stuff, webinars and those sorts of things, that helps, I guess, ultimately lift the tide collectively, and try and manage that risk of key big decisions not being made correctly.
Yeah. We talk about smart city practice and that we're training practitioners. Obviously Smart City Council is a major part of developing the practice, because as we've discussed, it's different to traditional IT management. It's different to technology management. There are many more responsibilities. So they're collective responsibilities. It's not it's not an individual thing. It's a practice amongst peers. Okay. So just before we leave, Tom, and say goodbye and introduce our next speaker, I wonder what you think the horizon looks like. What do you think the important things are going to be over the next maybe 5-year time horizon, which is probably about as far ahead as we can see?
Yeah. So look, I guess what we're seeing, probably a couple of things. So I I guess everybody wants me to probably talk about AI, and I'll touch on that a little bit last. But firstly, we're probably seeing where I guess the tangential application of existing technologies and bringing them to bear in new and different ways and delivering different outcomes. So an example being, there's an Australian satellite company that builds micro satellites, low Earth orbit, that have now developed an application for low impact resource identification, so essentially resource exploration. So they will use satellite technology connected with sensors on the ground that enable them to then run scans and probes from low Earth orbits for exploration for rare earth minerals. So they're connecting, I guess, radar, satellite, and a number of different technologies, but looking to apply that to bring a really different approach to mining and resources. So something that had been done, the same way with digging holes in ground traditionally for hundreds of years. They're now able to do that in a sustainable fashion that's actually far quicker and more accurate. So great example where technologies are being applied in new and different ways. Then I guess perhaps touching on AI, we're seeing probably the take-up of AI is still, I guess, quite varied in its application beyond just some base generative AI, but certainly machine learning, and so capturing and utilizing data sets far more effectively and efficiently, and so using those across cities to do things like predictive preventative maintenance, to gather insights and run predictive modeling. That's certainly a big piece, and cities and governments using their data sets far more intuitively and accurately. And then probably the third big one that we're seeing is just the continued push to, I guess, citizen-centric design and application and use of technology. So, focus on the user experience and enhancing the user experience and interaction. So, using things, whether that be sensors, apps, even just design of placemaking and path transition and stuff for individuals where, the focus is on providing a more complete, more intuitive and enhanced experience for those individuals that are navigating and interacting with cities and communities.
Mm-hmm. Yeah, well, we could have a whole nother hour-long conversation about all of those, any of those topics, but unfortunately we're out of time. So I just want to say thanks very much for this conversation. It's been really stimulating. I hope our audience has enjoyed it. Thanks very much, Tom, for your time.
Oh, look, I loved it, Chris. Thank you very much for the opportunity. As you can tell, I could probably go on for a while on this. So, really appreciate the opportunity to talk. So thank you.
Cool. Thanks very much. Right, let's move to our next session, which is on electric mobility. We now have Khaled joining us. He'll be presenting us this very relevant topic. Khaled will show us how EVs and electric trains are reshaping the future of city commuting. He'll help us understand the impact of EVs and electrical trains on urban planning, the importance of charging infrastructure, and the benefits of transitioning to electric mobility for environmental sustainability as well. Khaled is Installation General Manager at CAF. He's also a member of the faculty board here at ZIGURAT, teaching on our master's program in Smart City Management.
So appreciate your time and would like to present a presentation about EVs, about electrical trains today, which are part of smart mobility. So we'll go to the first slide. Yeah, let us start about how do electrical vehicle work, or what does it mean. So I have a short video for you, just to explain about EVs, just to make the topic is interesting in the first.
Ever wondered how EVs get from A to B? Is it essentially the same as an internal combustion car, but wired up to a giant battery? Or is there some altogether more subtle trickery afoot? Join us today as we pop the frunk and ask, how exactly do electric engines work? Surprisingly, the operating principle behind most modern electric vehicles predates the internal combustion engine by a number of decades. In 1834, a Dutch professor named Sibrander Strating of Groningen, Netherlands, built his own small electric vehicle. The catch being, its battery was non-rechargeable. Internal combustion engines work on the principle that fuel and air, when compressed and ignited, cause a tiny explosion. That's the combustion part. This explosive force pushes a piston. That piston's linear motion, in concert with a team of fellow pistons, transforms into rotary motion via a mechanical crankshaft. This in turn spins your wheels along the highway. Conversely, the fundamental principle that drives electric cars is magnetism. Everybody knows how opposing poles on a magnet attract and how alike poles repel each other. So let's imagine an experiment using two magnets, one fixed, the other mounted on a nearby rotating shaft. If the two poles nearest to each other on both magnets share the same polarity, say north to north, the magnet on the shaft will be repelled. Because it's attached to a shaft, the shaft will turn. That is until the south pole on the shaft magnet is aligned with the north pole on the fixed magnet, whereupon the shaft will again be still. In our imaginary experiment, we've made the shaft turn a half rotation. All very well, but that won't get us very far on the morning commute. Here's where electromagnetism enters the chat. In a fixed or permanent magnet, like the kind you have on your fridge at home, those magnetic poles are rigid and never change. North is always north, south is always south. On an electromagnet, however, which is essentially a core of metal coiled in electrical wires, this magnetic polarity can be reversed. Imagine one of our experimental magnets is now an electromagnet. If the south pole quickly flips over to north, the fixed magnet will yet again repel the moving magnet, rotating our shaft another half spin. That's a whole spin now. We're slowly getting there. For a basic illustration of how this polarity reversal works, imagine a very simple circuit involving a battery and a light bulb. Electrons flow in one direction from the battery, through the wires, to the light bulb, and back again to the battery. If we remove our battery from the circuit, flip it 180 degrees, then replace it in the circuit, those electrons will still flow around the circuit, just in the opposite direction. Either way, the bulb lights up. Electromagnets, like light bulbs, work whichever direction the electrons are flowing. But rather brilliantly, the polarity of the magnet gets reversed with the flow of electrons. So to keep our magnets in permanent repel mode, we just need to keep reversing the polarity of the magnet. How do we do that? One way would be to keep popping out the battery and flipping it around. But that's a lot of trips to the mechanics with your EV for the sake of a few feet of ground covered. So the real trick to making our magnet spin, which is essentially how electric motors work, is through the so-called inverter. The inverter module on the EV draws direct current from the car battery and, through a clever combination of quick switches, slick circuitry, and capacitors, flips the flow of electrons back and forth nearly 60 times a second. Domestic electric motors, like the one you have in your hairdryer, don't require an inverter. Why? Because the current that comes from your wall outlet already flips back and forth. That's why it's named alternating current, or AC. Batteries of any type can only ever produce DC, or direct current. So spinning magnets driven by alternating current passing through coils of wire is essentially what drives electric cars. Electric powertrains have a number of advantages over the internal combustion engine. For starters, the motion produced by the motor is already rotary in nature. Dirty pistons on an ICE require a complicated breakable crankshaft just in order to turn their linear motion into rotary movement. So EVs are less likely to fail or require expensive time-consuming maintenance. Here's another clever thing about that inverter. By adjusting the frequency and amplitude of its newly created AC current, the vehicle's speed and torque can be finely calibrated by its driver. There's no such fine control built into an explosively hot internal combustion engine, which is why expensive and accident-prone additions like gearboxes are a tiresome necessity. Another nifty detail about any EV's powertrain is when the shaft-mounted magnet, or rotor in engineering parlance, is itself spun, it generates electricity. This reversal very handily recharges the car battery. How can the rotor be turned, you ask? With any hefty source of kinetic energy, like, say, a braking automobile, which is handy. This is, to be clear, a very simple overview. There's different types of electric motor, and refinements to the design are happening all the time. Not least at one particular Californian car company named for the 19th century genius who discovered the magic of alternating current by himself, Nikola Tesla. What do you think? Will your next vehicle be an EV? Let us know in the comments. And don't forget to subscribe for more. Ever wondered how EVs get from A to B?
Okay, so after the first video, we'll talk now in details about how our electrical trains are shaping the future of city commuting. So we'll talk about the first point, environment impact. We'll talk indeed, I'll show you next slide, a video about environment impact, and the second point about efficiency and reliability. And the next one is, next one about reduce noise pollution. And the fourth one, integration with renewable energy. And the last one is infrastructure development and capacity. For sure, about environment impact, it's a challenge for all the countries now to reduce the emissions and to produce fewer CO2, reducing air pollution, and to be aligned with the climate change and enhancement. About efficiency, they offer for sure AV and electrical trains shorter travel times, increase faster acceleration. About noise, electrical trains or AVs, we can see that because no noise at all. Even starting with the electrical trains now, there is noise barrier to maintain that, to ensure that no any noise comes out of the train. About the next point about renewable energy, we can use the solar cell, we can use wind turbine, we can use different options of renewable energy, which are part of smart cities also. About the last point about infrastructure development and capacity, investment in electrified rail lines, and it creates jobs and increase transportation capacity to accommodate growing urban populations, which is most important point. Now I'll show you a short video about environment impact for the all diesel train, which is disaster. You can see this video. It's really, it was a very old solution, and now with electrical trains, now a big difference. We cannot see any CO2 or no any emissions, so we are aligned with the climate change improvement. Now, again, we'll talk about the impact of AVs and electrical trains on urban planning, which is the main core for this presentation. We'll talk about infrastructure development. For sure, urban planners must develop supportive infrastructure like charging stations, electrified rail lines, rectifier rooms, how we can develop, and how we can ensure that no one will suffer about from where he can charge his vehicle. The second point about land use. Planning needs to consider that space allocation for charging infrastructure, mixed use development near the transit hubs, near the transit station, and walkway also. It will be a friendly walkway for friendly environments. The next point about transportation networks. Planners must optimize transportation networks to accommodate electrical vehicles and train as much as we can, including dedicated lanes and smart traffic management system. Now, recently in the such countries like even developed or developing country, they started to put specific lanes for AVs, specific lanes for the cars, sharing cars, even for the buses. And the next point about environment consideration. Adoption of AVs and electrical trains can reduce pollution and emissions. If you remember in the previous slide how the diesel train was, with emission of CO2 and pollution, it was catastrophe. So about environment consideration, we can talk about influencing urban planning strategies towards sustainability. So this is an important point about this is revolution. And the last point about accessibility. It's essential to ensure that equitable distribution for electrical transportation infrastructure to all communities, poor, rich, black, white, old or young. So all of them, they have the same level of transportation and will be have, it's a fair for all of them. Also addressing of barriers to adoption like cost and accessibility also. I will show you the impact also for electrical vehicles, how we can also maintain that to be charged in the duration, it's very short duration. So for example, this short video show us how the buses can be charged in short time. By the way, this is the duration for charging is around 30 seconds, so it's nothing. So you can see the bus, drop in, drop, and the people get in, get out, and at the same time the buses getting charged in 30 seconds. So this is it's a good duration. It's something it's challenging also. And the benefits for transition to electrical mobility for environment sustainability. For sure, we are talking now and previous on the countries now, they are talking about emission reduction. Electrical vehicles significantly reduce harmful emissions, CO2, CO1, and improving air quality and public health. So we can say, I cannot live in this country because a lot of pollution there, there are no fresh air. So I need to go to villages, I need to go to cities. Now with AVs, we can live, all of us, in the smart cities with health condition. The next one, climate change mitigation. Absolutely lower greenhouse gas emission contribute to combating climate change and reducing transportation sector's carbon footprint. And the next point is about energy efficiency. Electrical vehicles, AVs, are energy efficient, leading to reduced energy consumption, promoting sustainable resource use and recycling. And all this one is, according to sustainability principles. And the next one, promotion of renewable energy. As we mentioned before, we are talking about solar cell, about solar energy, wind turbine. As we mentioned many times, solar, sun is free for all, so we can use this advantage. And then the last one, noise reduction and resource conservation. AV contribute to noise reduction, as we mentioned before. Also require fewer natural resource of operation, enhancing over environment sustainability. Now, we talk a lot and we have seen videos about EVs. I would like now to talk about the electrical train. So the interesting engineering behind electrical train. I have a short video to show you about electrical train. The principle, if you remember 3 slides before, how it was the emission from diesel train. And this will show you an electrical train, clean energy.
It might be surprising to know that in electric trains, the power collected from the overhead lines ends up in the grounding cable of the track after flowing through the wheels. 3-phase power conversion, regenerative braking, and zigzag overhead lines. All these make electric train technology quite unique. Let's understand all the engineering secrets behind the electric train, starting from the simplest design possible. The simplest version of an electric train is shown here. Here, a single sliding wire collects electric power from the overhead lines. This power is fed to a single-phase induction motor. The induction motor's rotor is connected with the wheels. To complete the circuit, the induction motor's other terminal is grounded. This grounding connection is possible because the wire is first connected to the wheels through an axle brush. The wheel is always in contact with the track, and the track is grounded, as shown. You can see how the current from the OHL flows to the ground. It first passes through the induction motor, then the axle brushes, then the wheels, and finally to the track and ground. When the current passes through, the induction motor's rotor spins, along with the wheels. However, a spinning wheel will move forward, which means the next grounding circuit should be available at a very short distance from the previous one. Now, let's look at some axle brush details. The axle brushes are fitted to the rotating wheel, and the current is transferred to the wheels through these carbon brushes, which slip over the disc attached to the wheel axle. Again, this is the simplest version of an electric train. Now, let's improve this design and make our train more functional. The voltage used in the overhead line is 25 kilovolt, which is a huge voltage. Motors require much less voltage to run. For this reason, we need to feed it to a step-down transformer, which transforms the voltage to the desired level. The power supply from the overhead line initially passes through the transformer's primary, and here, the circuit is completed due to the grounding. Because of the transformer's action, the current will be induced in the secondary winding and reduced voltage power is fed to the motor. For high traction like the train, the motor should supply a high torque. Moreover, the torque curve should be uniform, even if the motor speed varies. Three-phase induction motors are the perfect choice to achieve high, uniform torque requirements. Stretching three-phase wire to power this motor is not a good idea, as it's highly uneconomical. That's why a rectifier and inverter is used to convert the single-phase supply to the three-phase supply. A rectifier converts the single-phase AC power into DC power, and then the inverter converts the DC power into three-phase AC power. Now this engine is ready to run over the track. We can increase the torque output further if we add a transmission system with some gear ratio between the motor shaft and the wheel axle. At this point, the engine we just made seems perfect. However, if we make a complete train by connecting several coaches to this engine, it becomes quite clear that the single motor engine we developed doesn't have sufficient power to pull all these coaches. So, let's add more motor wheel pairs to make the engine more powerful. An engine bogie is constructed with three-phase induction motors, obviously to drive 3 pairs of wheels. In an engine, generally 2 such engine bogies are used. In this complete engine, you can see how the transformer and rectifiers are positioned. So far in this video, we've shown how we transfer power to the train using a single hanging wire. However, this method is not practical. Sometimes it is not possible to keep the distance between the train and overhead line the same, which means for proper power collection, a height-varying mechanism should be used. Pantographs accomplish this task. A modern pantograph looks like this. You can see that based on the pressure of a pneumatic system, the pantograph can adjust its height. If you observe carefully, you can see that during this height adjustment, the current collector remains horizontal. The current collector has to be perfectly horizontal. Otherwise, power transmission will be in trouble. We hope from this animation you can understand why the current collector always remains horizontal. For more details of it, please watch our detailed video about the pantograph. Now, let's see the pantograph in action.
So I will cut this video here just to be aligned with the time Chris give us. What do you think, Chris?
It might be.
So I'll talk about smart mobility can prove to be cost effective in the long run due to several factors, because I have received a lot of questions about smart mobility. It's worth to implement it in the countries, in the smart cities. Yes, the answer is yes, because I have many reasons there. You can see here, smart mobility can prove to be cost effective in the long run due to several factors. Efficiency gains. Smart mobility reduce congestion, travel times, and fuel consumptions, yielding long-term cost saving for individual and business. Imagine that every day 3 or 4 million trips have been reduced because the people they started leaving the car and using the smart mobility, public bus, trains, metros, AVs, also sharing cars. So it's efficiency gains. The second point, infrastructure optimization. We need to remember that technologies like intelligent traffic management extend infrastructure lifespan and minimize the need of costly expansion or repairs. And the next point is reduce externalities by curbing emissions and congestion. Smart mobility mitigates negative environment and health impact, resulting in a significant long-term societal savings. So our health now is in the good direction. And the next point, data-driven decision-making. Data analytics optimize the transportation systems, reducing waste, and thus saving costs. All these points, it's saving costs for us also. And the last point, PPP, we can say public-private partnership, collaboration, leverage resources effectively, sharing cost and risk to achieve mutually beneficial outcomes. And all the points can answer the question: smart mobility save save money and cost effective? The answer is yes. The last slide will be about a small video about EVs again.
So, electric cars. Really? How? When? Where? Everywhere? Yeah, you better believe it. The future of driving will be powered by plug-in. Across the world, countries are implementing bans on the sale of new petrol and diesel cars. For example, in the UK, the deadline is 2030. In Canada and California, it's 2035. And that is forcing the hand of the auto industry to make some big changes. Billions of dollars are going into creating greener vehicles. And some of the biggest manufacturers in the world are buying into this electric revolution. The trail is already being blazed by the likes of Tesla, and there are new kids on the block too. So, yes, buying electric is the future, but that doesn't make the future green. Not yet. Much of the electricity needed to power that trend is still generated by fossil fuels, exactly what we're trying to get away from. Clearly, there's little point in plugging in your electric car to recharge its battery using dirty energy. But as power grids become greener, it will become easier to charge up sustainably. Before that, though, they have to get the charge up to speed. A Tesla, for example, can supercharge about 180 miles of range in 15 minutes. But even that is 5 times longer than it takes to fill up with petrol. The good news is there's massive investment in battery research right now, leading to ever-increasing power and charge. But the next big challenge is rolling out sufficient charging points for the hundreds of millions of electric vehicles that will be quietly humming around in the coming years. There's something else, though. Batteries need rare earth minerals like lithium and cobalt to work. But current mining practices in places like the Democratic Republic of Congo are associated with human rights abuses such as child labor, and they often create pollution. So, supply chains must be transparent to ensure that the minerals mined for the batteries are sustainably and legally sourced. And a circular economy has to be developed so that materials are reused and recycled rather than continually extracted. But most of all, we must make sure the developing world does not get left behind in this revolution and just become a dumping ground for old petrol and diesel cars. Bottom line, there's a long way to go, but we know where we're going and we're heading in the right direction.
So the slides are over, guys. Do you have any question?
Thanks, Khaled. That was really interesting. I do have some questions, obviously. The first one is about electric trains. I know you've been involved in some electric train projects in different parts of the world, but I'm also conscious that electric trains have been around for quite a long time, as have electric tram systems and trolley buses in cities. You know, I grew up near Zurich, and Zurich has had an electrified public transport system for a very long time. So on the one hand, there must be a lot of data available in terms of cost effectiveness and things like that. But also, I wonder about innovation, like how much. Obviously, it's quite mature, but is there still a lot of innovation going on in this area? Is there still, the modern systems, are they a lot different from the systems that I grew up with 40 years ago?
Well, okay, for railway, we can say in general, railway now, there are a lot of innovation now. We can start from the old gold diesel engines. After that, they have switched to catenary system, which is a electrified system. And now the trends about battery train. So now will be the first tramway in the world in Saudi Arabia will be installed without any power sources, only in battery system, which is the most advanced system. So you can imagine that you cannot see no wires, no electrification system for visibility, for look and feel. It's only battery system inside the train. So the rail and the train tramway. So you can see where the innovation comes with. And they will install also renewable resources, renewable energy resources like solar cells, renewable energy. And all this innovation now, you can see the difference between diesel engine and renewable energy for the train. So all of this one, it's make cost effective for sure.
Okay, so that battery driven system, when is the battery charged? Is is it overnight, or is there wireless charging en route, or what?
It will be in a station. So, but in inter-stations, no any charge. So in station, it will be there is a charger will be installed there.
So it every time it stops at a station, it's topping up the charge.
Yeah. Okay. So it's nothing, because the dual time for trains to stop in the station around 1 minute or 2 minutes depends on the passengers, and in the 1-2 minutes we can charge the train.
Right. So tell us about some of the projects you've been involved in. Where were they, and what kind of systems were installed?
Well, I have been involved in a Riyadh Metro project, Cairo monorail. Currently, I'm working in Jerusalem LRT. And I was also designing phase for Copenhagen, Denmark, and all of them clean energy railway, no more diesel. All of them, we could talk about third rail, catenary systems, and hopefully my knowledge will be expanded also to see the battery system railway. Mm-hmm.
Actually, Copenhagen is a good one because, one of the benefits obviously is noise reduction. And I think this is true. Copenhagen introduced a ban on combustion engines for construction work last year or the year before. I don't know if you're aware of that, but reducing noise pollution as well as emissions is a big deal, right?
I can mention something about noise pollution because, as mentioned in the beginning of the slides, we are installing also noise barrier where we have a lot of homes, a lot of, for example, university, hospitals. On the track, we are installing noise barriers to maintain that no any noise coming out of the train. So we can ensure that the people, they can sleep well, the university can go smoothly for education without any new noise pollution. So it's also something of innovation for the railway.
Yeah, great. It also strikes me that, like with smart cities, obviously we're measuring a lot of things that we didn't measure as much before, and obviously noise sensors, emission sensors, pollution sensors. We now have a lot more data, and our cities are transforming as well. So a lot of our city centers are now, less driven by retail and people going into the city centers to shop. And a lot of cities, certainly in Europe, are transforming into being more residential, and schools are being built in city centers again for the first time in quite a long time in some cities.
Absolutely.
So do you think that the rationale is just getting stronger for electric power trains in cities because of the amount of data we're collecting on these other factors?
I can answer this question with one example. During the construction of railway, also we are ensuring that the noise pollution is very less. So, for example, if we are building electrical trains or during the construction phase in city center, we need to maintain that the people around us, who is living around us, they are not, getting frustrated or exhausted because of the construction works. You can imagine if we are caring about the noise during the construction. So the final solution of the railway should have no any noise at all. And this is part of the contract with any government. So they said, okay, for example, noise should be maximum 2 dBs or 10 dBs or 100 dBs. So they define for us how many decibels for us to the final solution will come. So if any pollution, noise pollution will not come from AVs, even not from electrical train. It will come maybe from another sources, not from our smart mobility sector.
Right. And you're compiling the data for that. You're actually sensing it so you can prove the fact.
There are some sensors. We're installing some sensors about microphone, just to like noise sensors also. In case, like in airport, for example, there are noise sensors in the airport. When we have any platform of the airport, some noises, the speakers will go up for the sound. So any people, they can hear the sound of the platform, the train is coming. In the city center, also same. We have noise sensors in each platform.
Right. Just finally, final question before we leave you. Obviously, the electric drivetrains, electric public transport are going to be disrupted by automation and autonomous vehicles as well. So where do you see that connection between EVs and autonomous
Well,
where's that going? Where is it at the moment? Is it going to be a big cost saving? Is it going to enable things that don't exist at the moment?
Well, driverless metros now started to be in operations. For example, in Dubai, there are driverless. In Paris also. In Riyadh Metro, it's a driverless metro, no driver at all. It's called automation of Go 4. So no drivers inside the train. And interfaces with the roads, and to make sure that autonomous vehicles to be a part of this smart mobility is highly recommended. And started, for example, in the junctions in the city center, when we have the road junctions or the cross junctions, we are installing also sensors where with the traffic lights. For example, if the train will cross the sensors, all the traffic lights will be red. It will be likewise also for the AVs and autonomous vehicles. When we have specific lanes in the beginning for autonomous vehicles, it should be communicating each other with the train, with the walkway, also with all the traffic signals there. So it's the interface between them. It's high, and all of them should be in the same software, same control center. So right. no any conflicts, no any gaps between them.
Yeah, so a big interconnected system, all monitoring itself.
Yeah.
And every vehicle within it.
So for sure it will require a lot of investment about it, but it will happen. It will happen as we have driverless trains now is working in the world, so it will happen this one. Yeah. And it's opportunity to be invested for all of us and about the research.
Awesome, thanks so much. It was a really clear account of what's going on in EVs generally and in city mobility. So. Really appreciate your time. Thanks so much, Khaled, for joining us.
Thank you, Chris, and all the best. And I'm sure next time we'll have more initiative and more ideas, smart ideas.
Yeah, absolutely. Let's do this again. Okay, so now let's get to our final session. It's entitled Smart Urban Planning, the AI and Computational Design Edge. And I'll be talking to Victor Calixto, who is a computational designer and research fellow at Monash University. Victor will share with us his Megapolis toolkit for data-driven urban design, which you used AI and data visualization tools to turn 50 subjective parameters into 5 objective ones. So hopefully he'll help us understand how urban planners can make better decisions through computational design. Hi, Victor.
Hello, Chris. It's a pleasure to be with you here.
Great to talk to you. So firstly, why don't you just introduce yourself and talk about what inspired you to pursue computational design in the first place, and kind of what it means, what the term is about.
Okay. I have been working with computational design since 2009. I was in my undergrad students that time, and I have had the opportunity to participate in one of the conference that are part of the CAD Futures Conference organization, which is the ZIGURAT. And I have the opportunity because it happened that year in the university where I was doing my undergrad, Mackenzie University. And since then, I just, realized that I would like to work with computational design. I think that in that time, we had other names to call it. Because it was not clear, there's not a clear definition at that time about the term. So we call algorithmic design, something called parametric design, bio-digital. There are all of these different approaches of thinking about the design what today we call computational design as this way of thinking the design in a more systematic manner, and making using of the computational tools to support this systematic way of doing things, right?
Right. So computational, by calling it computational design, it means that you can apply a lot of different techniques. It leaves it open as to what advances in digital technology and computer science, visualization that you're able to apply to design practice, I guess.
Yes, it applies on different. It's making using of I think that the term the field, which is not a new field. If we've gotten the records from the research, it starts with the design methods movement, right? In the 70s, the design will try to search for more systematic ways of thinking about the design, right? And the more systematic ways of design, and the use of the computer was one of the fields that was explored during the time, right?
Yeah.
That could make the project, the design more systematic, more. I think that much of these come from the book from the Albert Simon as well. That is because of the science of artificial and all this thinking behind this systematic way of thinking about design. And now of course we have much more computational power nowadays, right? And I think that this helped to make the field flourish even more recently.
Yes, we're a world away from the 1970s. So in terms of computational power and where Moore's law has got us, so the ability to ingest vast amounts of data and then do complex calculations very quickly, that surely is revolutionizing architecture generally.
Is they use the computer as a partner, right? And use the power of the computation to help you during the creative process. So talk
to us about what that looks like. Like where has that idea taken you in your research?
Sorry, could you?
Where has that concept taken you in your research?
Okay, my research is it's about related to how you could help them or help to assist the urban designers to make more evidence-based decisions, right? When I think when we deal with the city, we are dealing with a complex system, right? By definition, we are dealing with which it's almost impossible to have the clear picture of all the layers that the city has, right? And all the layers that interact.
Yeah.
And also all the socio-political actors that have their own interests and views about the city. So we just have one single and one small snapshot of this understanding, right, of the city. We cannot see the whole. And urban planning is very hard discipline, right? And urban planning, urban design, because we deal with this complex context, right? And I think that the computational tools in some way can help the planners and designers to have a better snapshot through the use of the data. And I think that it becomes even more important now with the emergence of the smart infrastructure and the availability of open data. So how you could get all these that are available for us now and improve the way that we make decisions about the city from a designer perspective, because it's a multidisciplinary field, right?
Yeah, very much.
Yeah, it's a multidisciplinary field, and in other areas also dealing with data in different manners, how you could approximate the urban designers and architects from this world, right? How you could help them to talk in the same language of the other stakeholders, right?
Yeah.
I think that's one thing that's very important.
Yeah. So is the idea that your toolkit provides that common language, that common view, and that different stakeholders that might be involved at various points in the design of a new building or district or transport interchange can see each other's data in that and can understand the perspectives of others, because they can see how that perspective comes from like a view of the world and a set of data, a perspective, and you can all see it inside the same environment. So this is what we would call a digital twin. Is it not? Is this the kind of area that you're in, or is it something different to that?
Yeah, my things I call like data-driven design. But I think that is part of course, of the digital twin as well, because the digital twin, I think it involves also the tracking of real data, and from that perspective, you're talking also about the design phase, that we need to take more decisions in the design phase. Of course, the digital twin will inform the design phase as well. So, but yeah, what I was trying to say is that, like, we have the language. We are working in a multidisciplinary field, right? Mm-hmm. We have the language that we have the data in the smart infrastructure, and we have these two different views, or even more than two different views, right? We have multiple views of these data that are available in the smart infrastructure, multiple interpretations of how you could actually tackle that. And for example, if planners and urban designers can understand the city in a way, but they don't have the set. They require two different set of skills. So that's what I'm trying to say. Because if you're a data analyst, we could navigate in a more efficient way, in a more easy way, to understand this data. But you don't have the know-how that the urban designers and urban planners have about the city. But in another case, if you are an urban designer or urban planning, you don't have the set of skills that the data analyst you have to make use of this smart infrastructure and make use of this data and navigate through this world. So I think that's a very challenging area. Mm-hmm. And I believe that one of the clues, or one of the approaches that could combine these worlds together, or could collide these worlds together, is through computational design. Mm-hmm. I believe that computational design is something that have been investigated, as I said, since the 70s. Yeah. And with these new visual programming tools that facilitate the new urban designers, architects, and urban planners to enter in this world, right? Could be the one of the ways that you could approximate these two worlds together, mm-hmm. and make the designers and the data analysts talk in the same common language, or could exchange ideas. Because at the end, what is important is this exchanging of ideas, right, from different actors, right, and different agents.
Okay, so your view isn't that that a software toolkit or a software application replaces the data analysts, but that the field of computational design provides a common language for urban designers and planners to have a proper conversation with data analysts, because better design emerges from that conversation. Like, it's too complex to just replace that capability of being able to make new data available and clean it and turn it into something that actually provides value. It's too significant to just delegate that to a platform. So
we cannot have one single professional that are going to deal with the city, right? We have multiple professionals, and with these new disruptions in technology, it's very important that everybody could talk somehow in the same language and exchange ideas. I just believe in the city that could be made by a diversity of professional and the people and also the citizens. I think that's another part that is very important, right? Because we are in a feedback loop, right?
Yeah.
And somehow we should involve the citizens in this process as well.
Yeah. I mean, one of the I think under-researched aspects of the digital transformation of cities is that citizens have an incredible power to self-educate. So things that used to be the purview of trained professionals are increasingly being able to be opened up to self-educated amateurs. There's a lot of expertise in the city. There's a lot of citizens have expertise. A lot of communities can be shown how to do this, some of these things, and some of those barriers should be falling away. But one of my kind of pet things is I don't think leaders and administrators have really understood how skills development can influence or should influence how citizens engage in the design of their city, the co-design of their city. But do you think computational design is an enabler for that, or do you think it's a bit of a barrier? I mean, it sounds technical, it sounds a bit complicated. How do you think it can be made accessible to a wider range of people?
Okay, yeah. Sorry. Yeah. I believe one of the points, right, is that we should make this available and what I'm going to say, like the citizens, because by the end, what I'm trying to say here is like when you think about the smart cities, we should think for who you're making the smart cities, right? I think that's for who and with who.
Yeah.
Right. I think it's the main point, like, because of course we could just put a lot of sensors or put a lot of technology in the city, not make the city smart, right, by itself. So, but that's why, and if you don't have the engagement with the citizens in the process in a way that they could contribute with technology, that I'm gonna touch on this point. We're just trying to to build this narrative. Mm-hmm. If you couldn't engage with the citizens, engage them in the process of trying to drive the technology, to drive the technology, by the end we cannot have smart cities without the smart citizens, right? With the citizens that really engage and really understand what are the purpose behind all of these technology apparatus that we have in the city, right? I think that one way, of course, the computational design, getting your question, the computational design can be one way, depending as other technologies can be, but depending on how you treat the technology. So, one way that I try to somehow address during my thesis is trying to make use of open source technology. I think that open source technology is one opportunity to invite the community to really participate in the process of the shaping the tools that will shape the cities, right, in the future. And we cannot have that if we just have like proprietary pieces of software. Of course, you could have the participation in some. It's not all blue. It's not all black and white, right? But one way of dealing with that is starting by making the tool development accessible for not just for the developers that could contribute to that, but also for the users, if you want, for a broader community that could make use of these tools, right? Or these pieces of software. So
right.
Yeah, I think this are related to if you have like the right to the city, the discussion is right to the city, we should have like the right to the smart city as well, in a way that could enable the citizens to participate in this process and have like a active voice on that.
Or at least even just know how data is being used and for what purposes, and how it feeds into the whole design process, how decisions are made about changes to the city. So talk to us a bit about the toolkit that you've developed, the Megapolis toolkit, and how, the tagline is that it turns 50 subjective factors into 5 objective ones. Talk to us a little bit about what that means and the purpose of it.
Yeah, Megapolis is an open source tool for Blender, which is an open source modeling tool, and it's very short, which is similar to if Grasshopper and Dynamo, which is a visual programming language that make easier the process of creating algorithms for design, right? For design or for analysis or for there are different purposes. It's a visual programming language that you can create things, right? And it's very popular. This approach among like architects and designers. Okay. And they start to be introducing this programming world through these visual programming languages. That's how I also started. And the Megapolis, what I try to do with the Megapolis is creating this toolkit that could be modular and flexible, right? And somehow could systematize in a way the process of dealing with design and data. So systematize in a way that could be open enough to include the new demands, right? The new demands or the new technologies, because you cannot create like a holistic or closing tool that is going to solve all the problems if the city is changing, right? If the city is involved, if the demanding is changing, right? We need to make this flexible enough. So the way that I try to treat that, the way that I try to create that was creating tools for gathering, for analyzing, for generating and visualizing very broad themes. And among these themes, you have like different tools across different technologies. That, of course, the idea that those could be extended in the future is not like a closed list, but this includes data analytic tools, includes GIS tools, includes geometric processing tools, includes immersive technologies, and includes it's across 7 technologies. I'm just trying to remember all of them right now. But yeah, they're different technologies. But what I'm trying to say is that it's not like a closed list of technologies, right? Yeah. Because the technologies will evolve, and some of the technologies will some of the tools will probably die in this process, right? They're not going to be more supported. And we need to somehow make this systematic, but at the same time flexible enough to somehow absorb these new technologies and these new demands. Okay, so if I understand this correctly, cities have data everywhere, right? They're locked up in different systems and different, cloud storage solutions, and they're all of different types, different data schemas. They were collected for different reasons, often not, with the thought that they might be useful to someone who's trying to make a change to part of the city or
part of the transport network or part, the infrastructure. But what you're saying is your toolkit has a framework where if developers have access to a new set of data, they can easily write new modules, extensions to the toolkit to that understand that particular type of data and how to get it, and how to manipulate it and transform it. And then they can add that, because it's an open source project, they can add that to the community at large, and then other cities can then borrow that code and reuse it for their own purposes, et cetera, et cetera. So ultimately, there will be lots and lots of different modules for the software toolkit for all sorts of different purposes. Presumably at both ends, like at the data gathering end, but also at the data visualization end, and the kind of things that you can do.
Exactly what I try to do with the tool. Of course, at the moment we have a limited set of tools. Yeah. Right. You have limited time of time to make the thesis and make the prototype. Right. I call it prototype. And I think that we're still a prototype for a long time, because I like the idea of prototype, right? Because the prototype, you're always improving, right?
Yes. And we used to call it endless beta. Yeah. The software is just in beta forever. Yeah.
But just mentioning what you mentioned about the I think that you mentioned about the five subjective qualities, right? And then just giving one example, one simple example. For example, one of the module of the toolkit, I try to make it with one specific purpose, which is trying to address some of these subjective qualities of the urban environment, right? Because I know that there are some, because if you look at the current AI tools, somehow they are doing a really great job on trying to work with objective measurements, right? We can work with the zoning, or we can work with this objective criteria, right? But there's not much efforts on trying to look at this subjective part. That's very important. I believe that's very important. For example, just giving some examples of what I mean by subjective. When you talk about how you could measure the complexity, how you could measure the imageability, how you could measure human scale, how you could measure enclosure, how you could measure transparency, right? How you could get these concepts that are all in the discourse of urban designers. When you're dealing with traditional urban design, we are trying to address some of these concepts. We're trying to make that the people, for example, when we're talking about placemaking, we're trying to understand how the users or the citizens will use it, determine place, or it could make them feel that this could be a place, right, to be. And if you look at the current tools, they tend to focus on more objective measurements. And I think that there are one opportunity through the new advancements of data analytics and machine learning and AI to address these concepts as well. For example, as I'm saying, just going back to the module, I just trying to create one module because there are some research that I'm trying to understand the subjective qualities to objective measurements. Right? Okay. For example, there's a book that's called Measuring Urban Design. It's a book I think from 2009, which the research, in this we're reading his name, he developed a framework to measure some of the subjective qualities using some objective measurements. So what he does he did in his book, his research, was through some experts. He analyzed 500 different blocks on Boston, and using experts to try to understand what are the characteristics of, what are the objects, what are the elements of the urban environment that could potentially give one direction or measurement of these concepts. For example, we could measure how transparent is specific lane, trying to understand the percentage of transparency of the ground floor, or we could measure the complexity, trying to understand the complexity of the facades, the elements that we have in the facades, and counting them, right? We could actually count them manually, but what he did at that time was to use these auditors in a form to check the elements, right? To check the elements and could get these measurements, right? He tried to validate 50, and he could successfully validate 5 of these concepts.
Right. Okay.
In recent research, I'm trying to make use of image segmentation to try to automatize this process, because it's very time consuming to have the auditors to go to the street, right?
Yeah. Yes, I've seen projects that use the Google Street View to determine whether neighborhoods are, have high livability scores and things like this.
Yes,
by counting benches and
of all these images from Google Street View.
Yeah.
Or in that case, my tool I use Mapillary, which is a crowdsourced initiative that's similar to Street View, right? But it's made for by people that just upload the photos from the track that they make. It's a collaborative tool. I'm trying to integrate as much as possible of this kind of technology to make it more collaborative, because it's one of the view of the
so this is kind of in parallel to what we would call sentiment analysis, where you're trying to understand what people think and feel about a place through reading social media posts or doing consultations and getting feedback from them, or literally just asking people in the street. That's very subjective, and people give you your opinion, and you can analyze that to figure out what people think in the aggregate. But this is about visually looking at a place or understanding its dimensions, and all these other factors, and making determinations against those objective things that you're trying to achieve. You're trying to maximize in a good design.
Yeah, there's so much potential.
Yeah,
these new technologies and with this new advancements in the last years in other fields, for example, the large language models. I cannot imagine what this could actually contribute in different ways, right? Yeah. For example, if you think about the sentiment analysis that you could collect the data using Twitter, Yelp, or all these crowdsource, right? Sources of data. Yeah. And imagine if you combine with some large language model to extract meaning of that, to help to extract meaning of that. There is so many potential different areas that we could address this more subjective area. I'm not saying that objective area is not important. I'm not saying that. I'm saying that both areas are very important for urban design, and we need to pay attention to both objective and subjective.
So what do you think is lacking? Is it skills? Is it that urban designers need the skills to be able to do this, or is it just an understanding of the potential of it? Or is it that projects need to be more collaborative to bring more people from different disciplines together?
I believe in the collaborative. I believe in the collaborative, multidisciplinary, but it's very hard. Well, what we were just discussing before, it's very hard to make everybody to talk in the same language, right? I think that one of the main barriers is in this common platform, right? Common platform that could bring everybody together and discuss in the same language, right? Just getting one anchor for that as well. For example, that's why I'm also trying the visualizing tools, trying to create some dashboards, right? Because even if the designer, the urban designer, could not have yet the skills to deal with the visual programming tools, right? That's the open door to get in this language. You could have like a very good discussion if you have one that everybody could discuss in the same platform. And I believe that the use of the interactive dashboards, I tried to create an interactive dashboard that you could actually change it based on the visual programming in real time. So could bring another potential to put everybody in the table to discuss. So I think that the collaboration is the key. Multidisciplinary is the key. I think that's, of course, we need to it is in the not just in the urban design but in architecture. We need to see that the understanding computation will be a critical skill, right? Yeah, we know that we're going to be a critical skill that we already start to introduce that in primary school, secondary school. We know how to program and understand code, not just understand code, but understand the logics behind it, right? That's a computational thinking, right? If you think about computational design, it's the combination of the design thinking and computational thinking. We have one kind of intersection that's computational design thinking. And I think the computational design thinking will be a critical skill, not just for architects or urban designers or planners, but will be a critical skill for the future professional, because computation is in all areas, right? All areas, we have computation in all areas, and across all areas, computation will going to be like a common language. So we need to upscale. Of course, we need to do an upgrade on the curriculum of urban design and architecture, right? But it's not just about this upgrade, but it's about the collaboration, right? So we need to put everybody in the same table.
So is it a generational thing then, Victor? Do we have to wait another generation or two even for our young people to have grown up in an education system that teaches them computational thinking, so that it can really become established in our disciplines? Or, obviously we're at ZIGURAT, we're trying to educate professionals and trying to get these concepts and ideas more widely understood and known. But how do you see it? Is it something that's just going to take time, or is there a lot that we can do already?
I think that I'm saying that the computational design thinking will be very important for all the areas, right? And it already start to be implemented. I think that's a generational thing somehow, but we should start to be implemented in the primary school and the secondary school. All this computational thinking, right? And I'm saying that we just could think about the smart cities. If you think about the smart people, right? The smart citizens, and how we could actually this computational design thinking, right? It's going to be very important to glue, right? To combine, to connect all these different professionals these different dimensions that are very important for the smart cities concept, right? So we just could have these smart cities if you actually have these smart citizens that have this common language, right? They're talking the common language and exchange ideas in a common language, right? I think that's somehow that's why I think that's the fundamental role of the computational design thinking, not just for architects or urban designers, but across all different disciplines will be like a critical skill that everybody will need, right, in the future.
Yeah. Yes, and given that's really the foundation of a smart city, that it's smart citizens able to understand how data is improving decisions about how the city works, what affects their lives, and everything else. And then, of course, the transformation of all our professions, and what impact that has on productivity and the economy and quality of life and everything else. Well, listen, that's absolutely fantastic. I've really enjoyed talking to you. It was really interesting to see how technology can help us solve complex challenges in urban design, but also the relevance of all of that to the rest of the smart city practice and all these other disciplines.
It was really great to talk to you, Chris. Was a pleasure, and I would like to just thank you, all the ZIGURAT team, and you to have the opportunity to talk here.
Yeah, fantastic.
Talk a little bit from my perspective.
It's really great to have you on.
If you think about the smart cities.
Yeah, I hope we can have some more conversations about this, maybe offline when it's not being recorded.
That's going to be great.
I'd also like to say to everybody who's joined us, I hope you all enjoyed this event. I'd like to express my thanks to Tom and Khaled and Victor. We've brought together a group of professionals who have given us a really interesting and inspiring overview of how technology is impacting on cities today and the potential it has for the future across multiple different areas, multiple different disciplines, but are still interlinked with each other. So thanks again. I hope to see you soon. Please join one of our upcoming events when we talk to more people who are changing the way that cities operate and the way they're designed. Thank you.